Hello everyone, it's me Mr. Ramsey and welcome to the week 2 of our online class. So the topic that we'll have today is about the position of an object. So before we go to our main topic, let us review first about the topic that we have last week. So it's all about motion. So let us define what is motion. So motion is defined as change of position of a body in a given time. So when you say position, position is the place where you are. For example, I am in sitting position. So right now in front of the laptop. So I'm sitting now, and then when there's a change of position, like I will stand and go to the toilet. Okay, so from where I am going to the toilet, there's a change of position, so there is motion. So another definition of motion is it is always observed as the measure with point of reference. Also, it is motion is simply the change of position. So that's the simple definition of motion. So change in position. For example, turning the page of your book is one example of motion. So from one page to another page. Or the earth is revolving around the sun. So those are some examples of your motion. So what are the three types of motion? So these are your linear, your projectile, and your circular motion. So when you say linear, it's a motion in a straight line. Projectile, it follows a trajectory. So that's the motion that follows a trajectory. So circular, it's a motion that follows the circumference of a circle. So these are the vocabularies that we're going to um, use in this topic. So number one is grid. Let us spell the word grid. So grid is G-R-I-D, grid. Next will be dynamic. So dynamic is D-Y-N-A-M-I-C, dynamic. Next is static. Static, S-T-A-T-I-C, static. Next word is reference point. So reference point is spelled as R-E-F-E-R-E-N-C-E, reference. Point, P-O-I-N-T, point. So reference point. Next word is position. Position is spelled as P-O-S-I-T-I-O-N, position. Next word, it will be your perpendicular. Perpendicular. So how do you spell the word perpendicular? P-E-R-P-N-D-I-C-U-L-A-R, perpendicular. Okay, so let us go now to our main topic. So the main topic that we'll have is about the position of an object. So generally, the position of an object on a flat surface can be identified by comparing its relationship to a grid. So if these are the objects, so I have drawn here a dotted line. Okay, so these are some of the objects. These are building. Okay, so as you can see here, these are some of the buildings. So these are what you call your objects. And um, here it's a flat surface, so you can identify the object, the position of an object by comparing it to the relationship to a grid. So this one, the red line here, is what you call your grid. So these are the grids. This one, this one, this one. So these are what you call your grids. So what is a grid? So a grid is a series of lines perpendicular to each other. So when say perpendicular, it means the relationship of the lines that are meeting each other in 90 degrees. So as you can see here, the red lines here are meeting each other in 90 degrees. So these are the 90 degrees angle that you have. So this line meet each other in a 90 degrees. So this is what you call your perpendicular lines. Okay, so these are what you call your this is what you call your grid. Okay, so for example, let us determine the position of uh, these objects. So where these objects can be found. So example, for this building, where can you find the base of this building or this building? Okay, so you can find this building in column G and row 7. So the column is letter G, the row is 7. So this is G7. Next, this object. So this building here can be found in column letter H and number 4, row number 4. So the position of this object is H4. H4. So how about this building here? So this building here, the position of this building is column letter D, row 3. So the position of this building is D3. Okay, so these are some of the examples of how can you determine the position of one object based on the grid. Okay. Okay, so let us go to another example of how can we determine the position of an object. So we have here the classroom setting. Okay, you can see here teacher's desk and this the seat of the students. Okay, so where the students are seated. So here we can have here the vertical alignment of the students is what you call your column, and the horizontal alignment of the students is what you call your row. Okay, so column is what you call your column. So column 1, column 2, column 3, column 4, column 5, and column 6. The horizontal alignment of the students is what you call your row. So row 1, row 2, row 3, row 4. Okay, so the distance of the students in row 1, okay, to the front wall is 5 meters. Okay, again, the distance of the seat of the students from the front wall to their seat is 5 meters, and the distance of the first column students from the left wall is 2 meters. Then the distance of student letter A to student letter B is also 2 meters. Student B to student C also 2 meters. Student C to student D also 2 meters. And student D to student E is also 2 meters. Same here in row 2. So the distance of student G to student H is also 2 meters. Student H to student I is also 2 meters. Okay, so each row here, the distance between the students is 2 meters. How about the distance of the students A to G, the column? Okay, so what is the distance of the students in each column? So the distance of the students in each column is 1 meter. Okay, so let us determine, for example, what is the distance, what is the position of student letter C? So we can say that the position of student letter C is 5 meters. You can locate the position of student C 5 meters from the front wall, and let us count how many meters uh, he is from this left wall. So 2, 4, 6. So he is located 6 meters from the left wall and 5 meters from the front wall. So how about student letter G? So student letter G, you can say um, he is located so from the front wall, he is located 5 meters plus 1 meter, so that is 6 meters. So student G is located 6 meters from the front wall and 2 meters from the left wall. So how about student Q? So student Q is located 4 meters from the right wall, and let us determine how many meters he is from the front wall. So 5, 6, 7. So that is 7 meters from the front wall. Okay, so do you understand? So let us have some activity later. So let us go to the definition of a reference point. So what is a reference point? So a reference point is a fixed point in space used to compare the position of each particular object. So what do we assume when you say reference point? So we assume that the reference point is not moving or stationary, or it's in place only. So what are some examples of your reference points? So these are the roads. Okay, so these are the particular sites. For here, this is the tower from Paris, right? This one, a tree or a house. Okay, so those are some of your examples of your reference point. So another definition of a reference point. So the reference point is used to define as the position of an object. So it can be natural, objects around us, such as a river or a tree, or it can be anything man-made, such as road, a bridge, or a building. So let us go to dynamic and static objects. So in our life, we find either dynamic or static objects. For example, um, the chair. So the chair here, if you will not move here, if you will not move the chair, the chair is what you call your static object. But if you move the chair by pushing or pulling it, okay, it can be a dynamic object. Another one is your table. If you just let the table just stay in one place, so that table is in static position, or it is a static object. But if you move the table by pulling or pushing the table, or by lifting the table from one place to another, so that table becomes a dynamic object. So what are dynamic objects? So dynamic objects, these are the moving objects wherein the movements are from one place to another. So as you can see here is the example of a train. So when you see a train, so your BTS, that train is moving from one place to another place, or from one station to another station. So that train is what you call your dynamic object. So that's one example of a dynamic object. Another example is your delivery truck. So from the cargo truck. So if this cargo truck is from its office, okay, so they come from their office to get the things and then deliver it to your home. Okay, so that truck is a dynamic object because it travels from one place to another place. Okay, or example, you are walking. So when you walk from your place, example, you just walk, the distance of your house to school is only like 1 kilometer or 500 meters. So you walk from your home going to school. So you are considered as a dynamic object because you're moving. Okay, what are static objects? So static objects, these are objects that are stationary or stay in place or doesn't move. For example, these buildings. So these buildings here are not moving. So they are what you call your static objects. They're in stationary or stay in place. Example again is this tree and this bridge. So this tree here and this bridge here are not moving. Okay, so those are some examples of your stationary objects or static objects. So these are all for today. So for additional information about the topic, please view the video attached in the materials of your Google Classroom, and please answer the quiz attached to the assignment of your Google Classroom. So thank you everyone, and hope to see you soon. Bye everyone.